All right, so we are at lesson 2, topic 3, and I have Maria up close and personal here for you because she wanted to see what was going on. As I promised, we're going to look at an example that's almost exactly like what we did in class today, but we're going to use rational exponents to make it a little bit easier. So, 81x to the 5th over 3x squared y. Now remember we had 3 steps. The first was to squish together if we have more than one root. Second is to simplify underneath the radical, simplify inside, and then we simplify the actual radical, or I'll say solve. Okay, so first, do we need to squish anything together? Well, no, I guess I could have written this as the cube root of 81x to the 5th over the cube root of 3x squared y. I didn't in this case, but if we had, we could have squished those pieces together. We now have one root. We want to simplify inside. Now, 81 over 3 and x to the 5th over x squared are the two that I'm thinking of in particular right now that we could simplify. 81 divided by 3 is just 27, which you could figure out in your calculator as well, but I'm just going to tell you right now it simplifies to 27 over 1, or just 27 in the numerator. So that takes care of these two. X to the 5th over x squared, remember that's 5x's over 2x's. Or we could just use our shortcut rule that we made, which is if I have a power divided by a power, we subtract. 5 minus 2 is x cubed. So we just put x cubed up in the numerator. And then y, he's all by himself, so he has to stay down in the denominator. Okay, this is the part where I want us to write everything according to a rational exponent, not roots. So we would have 27 to the 1/3 power. We'd have x cubed to the 1/3 power, but if we take a power times a power, we multiply, so that would be 3 over 3. 3 times 1/3. And then y to the 1/3 power. We can simplify. This means we want to take 1/3 of the factors of 27. 3 times 3 times 3. So we want to keep 1/3 of them. We just keep 3. X to the 3 over 3, or remember this was x to the 1/3 cubed, would just be x to the 1, or just x. So just like that, we have the top simplified. The bottom is technically a root in the denominator, right? It's to the 1/3 power, but we're supposed to rationalize the denominator. We don't want to have y to the 1/3 power there. So we need to come up with a way to get rid of it. Now, in the last section, we then multiplied it by itself 2 more times. Y to the 1/3 times y to the 1/3 times y to the 1/3. Here we can think about it a little bit more simply. We want to multiply this by something that will bring us, we'll get rid of the exponent, essentially. So I'm going to write this down, and then we're going to discuss why I wrote it. So I'm just writing y to the 2/3, which I know we don't know why, but just write it down, and we're going to talk about why that might be helpful. Remember, we can keep a fraction the same as long as whatever's on the top and the bottom are the same, which is what I've done. Y to the 2/3, we don't know why, but I have, and y to the 2/3 on the bottom. Let's simplify this, and I think without me even explaining, you're going to see why we wanted to do it. We will go back and explain, but let's see. On the top, we just squish these all together. 3 times x times y to the 2/3. Nothing really interesting happens. On the bottom, we have a power times a power, or an expression with a power times an expression with a power. Remember, a power times a power, we add the exponents. 1/3 plus 2/3 is 1. 1/3 plus 2/3 is 1. So this is just y to the power of 1. In other words, we just have y. We just have 3x, y to the 2/3 on the top, and we just have y on the bottom. Which means we have rationalized the denominator. Now, let's see, where did I come up with this idea of finding y to the 2/3? Well, I knew that I could make the exponent disappear if I could turn it into an exponent of 1, which is what we did, right? Y to the 1. I could then have no exponents, and I would know that the denominator was rationalized. I should say denominator rationalized, to be more exact. Hi, Maria. You can't see Maria's face, but she's peeking over. If I had the camera, you'd be able to see her. I'm half tempted to distract you, but her song is probably distracting enough. Okay, so we want the rational exponent to disappear. I turned it into 1 by saying a power times a power. You add the powers. 1/3 plus what would be 1? 2/3. And that's why I came up with y to the 2/3, because I knew that 1/3 and 2/3 would make it all go away.